Anthony, welcome back to Talk Python to me again, again
Hey,
and again.
Mike.
So awesome to have you back. Always good.
Yeah, great to be here. Hey.
Good to catch up. Good to have you on the show. I know we've got a really interesting topic to talk about performance, load testing. How do you know if your website or your API is going to work when you ship it to the world in a real world way, not just how many requests per second can it take, but real use case, as I know you're going to tell us all about. So that's going to be awesome. Before we do, just quick introduction to who you are, and maybe for most 98% of the world who knows you, what have you been up to?
Yeah, so I am the Python advocacy lead at Microsoft. I do a bunch of open source work, maintain some projects and stuff like that. Wrote a book on Python, the Python compiler called CPython Internals. But these days, I'm mostly known as the person that created VS Code Pets. And that's which was a bit of fun, but has become the most popular piece of software I've ever written. So that's been interesting. It's now got over 1 million active users. I'm not sure how
Careful what
that.
you create. You might get known for it,
Yeah, I know. It's interesting when you go to conferences and stuff now, and I'm like, oh, I work on this project and this project, and then you mention the pets thing, and they're like, oh, you're the pets person. Oh, you're the developer of the. I'm like,
You spent a year writing a deep book on the internals of CPython and its runtime. I don't know who you are, but this pets thing is killer, man.
yeah, there's a cat that runs around in VS Code, so that's cool.
Can it be a dog as well? What kind of pets can we have?
Oh, there's everything. Yeah, it can be a dog. There's like chickens and turtles and snakes and yeah, everything you can think of. It's a pretty active repository as well. We get a lot of feature requests for new shades of fur and new pets and new behaviors and stuff like that. So
Yeah, that's incredible.
yeah, if you haven't checked it out, then check out the VS Code Pets extension for VS Code.
Yeah. I installed it for a while. I had to uninstall it. It was too much.
Yeah, I think if you're one of those people that likes having distractions, then
Yeah.
it's helpful. If you find it hard to have a little thing running around whilst you're trying to code, then it might be a bit much.
It's a little bit like power mode. Like,
Oh yeah,
are you familiar with the power mode where?
I used the one in JetBrains.
The,
Yeah, I used the power mode for JetBrains when that was around. It was pretty cool.
yeah, if you want maximum distraction for your work. I
Yeah, it
guess a
reminds me
lot
of
of
Unreal Tournament, the sort of power modes for that.
That's right. That's awesome. All right. Well, let's start off with some stories. So, I think everyone has a sense of like, why do you want your website or your API or your microservice thing of API and website, however you combine these things, to work well and understand? But it's always fun to share some stories. I know
Yeah,
you got
so
some.
we want to talk about load testing, and I think a fun thing to do with load testing is to reflect on times where people haven't done it the right way, and it's caused a really public disaster. Um, but the analogy that I use is the halftime problem, which I'm English, and so this is mostly a soccer thing. But we've got really big soccer games, and it would be the same, I guess, with the Super Bowl.
Yeah, I was just
But
thinking American Super Bowl, football Super
yeah,
Bowl
but the difference
is
is that
got to
in
be.
soccer, at 45 minutes, you've got a 15-minute break.
Yes.
Whereas in the Super Bowl, every 15 minutes, you've got a 15-minute break. So,
Well, and it's loaded with commercials. So you got
and
like every 5 minutes, there's like, oh, here's 2 more commercial breaks. Like, where soccer is a flowing game, there's like no break until halftime, right?
yeah,
That's the difference, I
exactly.
think.
So what happens with a big game? So if it's like a FA Cup final or like a Champions League final or something, then you basically have 100 million people all stop watching the TV at the same time for 15 minutes, go to the kitchen, turn on the kettle, make a cup of tea, go to the bathroom. And so the electricity providers actually have to plan for this, because a kettle uses like a couple of kilowatts of energy, and all of
Especially
a
in the
sudden,
UK where it's 240.
yeah, exactly.
Yeah.
And all of a sudden, you've got like tens of millions of people all switching on their 2 kilowatt kettles at the same time. So the electricity providers basically have to plan around the soccer games, so that they get this massive spike in load in their grid. So they actually do look at the sports schedules, to basically plan around this, especially if it's something like a World Cup or something like that. And this is kind of like a load testing thing where you kind of on the system is going to be, and is it a spike in traffic or is it like distributed? And occasions where it's gone a bit wrong. So here in Australia, we had a census maybe 8 years ago. And normally it's a paper census. You fill in the form, say who you are, what you do. But this time they wanted to do it online as well. And they really encourage people to use the online version. And they set up the system, set up the website, and said, okay, everyone can fill in the census. There's only 20 something million people in Australia. It's not a very big population. But on the last night before the census was due, it crashed because everybody logged on at the last minute and tried to fill it in, and they hadn't tested it properly, and it just wasn't ready for the load. And in the post-mortem, they said, "Oh, we did the load testing and we tested it and it seemed fine, but we expected everybody to fill in the census over the 6 months that they had to do it. We didn't think that people would leave it to the last minute, which is more like, well, what did you expect to happen? This is just human nature that you're going to put it off until the last possible moment."
Yeah, I could only see 2 spikes. A small spike at the beginning and a huge spike at the end, and like nothing in the middle.
Yeah, exactly. So they had to kind of delay the deadline and then provision new infrastructure and stuff like that. So yeah, it was interesting, but it kind of highlighted how you need to think about load testing.
Yeah, that's nuts. And I guess the mode before, the style before was kind of a distributed queuing system using paper envelopes where the queuing
Right.
literally was physical and then it would be processed at the rate at which the system can handle it, right? Which, however fast you can get them in based on paper. But then you try to turn it to an interactive system and oh no.
Yeah, exactly.
I have another example to share. Like we've seen websites that fall down like this. It fell down, and when something has to be done, I think it's probably really tricky to communicate. Let's say 10 million people tried to fill it out that day, and it crashed on them. Well, how do they know that the deadline's extended, and how do they come back? Right? Like it creates this cascading chain of really challenging problems all of a sudden to deal with it. We had the healthcare Obamacare stuff in the U.S. where as soon as that thing opened, it just completely died, and for weeks people couldn't get insurance, which was bad. But that's not the story I want to share. I want to share a different one. There was this app, this person who was frustrated about. They're an artist, like a photographer, I believe, and they're frustrated about LLMs and diffusion models taking everyone's art and generating new art from it, and kind of. I guess it's up to people's opinion whether or not it counts as stealing or copyright theft or it's fair use or whatever. But this person wasn't a fan of that. So they came up with a web app based on serverless that would look at stuff and say, this is real art. This is AI generated art. And it's not exactly the same, but they ended up with a $96,000 Vercel bill because when they didn't really take into account how much it's going to cost per request to handle this on their serverless. And it was like 20 cents a user, and everyone's like, this is right at the height of the LLM boom and all the AI art boom and stuff, and people just swarm to it. So that's a different kind of problem, right?
Yeah, that's the cost issue. Yeah, there are definitely other ones to keep in mind. And we mentioned, like, the census and the Obamacare thing, and you might be listening and thinking, well, my website's not going to get 15 million people logging in all at the same time. So, like, is this really an issue that I need to handle? Like a few months ago, I was doing a load test of an AI app, so like a chat app, and designed the load test and ran it with 10 users, and it had issues.
Yeah.
So, like, this doesn't need to be a tens of millions of users problem. And the issue that it uncovered was like, oh, there's a rate limit on the number of tokens you can send to the LLM, and by default, it's a really small number. And if you have 10 people asking questions simultaneously, then that gets exhausted
overruns
really
it.
quickly, and it just throttles you. And then, like, the app just says, "Oh, rate limit error," and you just wouldn't have noticed, because if you're a single user clicking around, typing in, questions, or even if you've written some fancy, like, UI testing or something, you're like, "Oh, we've tested it and it works great," but you run 10 people using it at the same time, and that's where you start to notice problems.
Yeah. I've more than once considered putting some kind of LLM AI augment, RAG sort of thing in front of TalkPython, because, God, at this point, 8, 9 years of full transcripts, human corrected, with all sorts of, pretty highly accurate stuff. It'd be awesome to have people have conversations about it, but I don't know, just the workload. I can see so many people coming to you and go, "That's neat. I'm going to ask it about my homework." It has nothing to do with it. Just using it as like a free AI to just, instead of bothering to download something or use ChatGPT, I'll just use yours. And I'm like, probably not worthwhile all the trouble.
Yeah, you can set them up so that they only answer questions about your own stuff. They don't act as a fancy front end for ChatGPT.
Yeah.
We've got plenty of demos that are like that. You give it your own internal documents, and it only answers questions about those. And you can set it up so that if it can't figure out a reliable answer, it tells you. It says,
that's
I
great.
can't, rather than just making something up.
Yeah, that's really nice. Yeah, I forgot how closely you guys work with OpenAI and all that,
Yeah.
right? Yeah.
Yeah.
I mean, the compute in Azure to run and train all that stuff it's out of control.
Yeah, the GPUs alone are insane.
Yeah, it's, I talked to Mark Rasanovich, a bit of a diversion, but about some of the hardware and some of the data center stuff, and it's like we're gonna create distributed GPUs that connect back over fiber to the actual hardware, so you can scale your GPUs and CPUs independently. Like, there's just all kinds of crazy, interesting stuff there. But that's a bit of a side note. All right, so let's talk about basically, what do you want to do to design a load test? Like, it's more than just, let me write a loop and see how many requests I can make, while true, call, use request and call this endpoint or something, right?
Yeah, so there's, I guess, what I normally highlight with load testing is that the wrong way to start is to try and work out how many requests per second your server can handle. Like, that's interesting for throughput, but it's not a good measure of like real user traffic. And the main reason is that every user is unique. They do different things. They follow different paths. They put in different data. And also, when you're running like a benchmark, then it's not waiting between requests. It's just trying to hammer as much as it can. So real users pause and read and click and wait, and there's normally latency. I can see your mouse moving, Mike, but I can't hear you.
Sorry. So
no, I can.
They don't request the same page over and over and over, right? They request a blend of pages. Here they go to the homepage, then they do a search, and they explore what they find in the search, and they go back and do another search, and then they go to checkout or whatever, right? And as you're pointing out, they don't just hold down Control or Command R and just flicker the screen as hard as they can. They're reading and they're interacting. And so what you're saying is, if you really want to say how many actual users, not just kind of a throughput number, but how many people using the app do you possibly expect it could keep working, or right? You got to factor all these things in, right?
Yeah, so you've got to factor in the randomness of where they go, what they type in, the weights between each click or each API request. And then something else that's really important is that most modern applications, it's not just the initial HTTP request, it's the 95 additional requests to all the scripts and the resources and the Ajax calls and everything like that. So if it's a browser-based application, then typically, it's not just the initial request, it's everything that happens after it. And I've definitely seen times where people have done a load test and said, oh yeah, the website runs great. And then in their app, they had like a JavaScript poller that would like refresh the data or something every minute. And then they didn't test that. And then you get, thousands of users who leave the tab in their browser and it's just polling in the background. So you've basically got this continuous stream of traffic to a special API that does like polling. And they hadn't load tested that, and that produced a huge like spike in load, and that caused issues.
It's like 75% of the workload is the polling.
Yeah. Yeah, exactly.
What's your browser tab story? Are you a person that just has tons and tons of tabs open?
I don't know. I try and clean them up as much as possible.
Yeah,
and have like a couple open maybe. Unless I'm researching something, and then when I'm finished, I just do close all tabs.
Yeah.
And then start again.
Yeah, that's me as well. I think there's a good number of people that just have like 50 tabs open. They just leave them. And think about what that does for your website. If you've got some kind of timer-based deal, right? You got to consider those people that have just left it.
Yeah.
Yeah. So
Exactly.
you got to take those things into account, I suppose. Yeah.
Yeah.
And you did mention that the CSS and you talked about the Ajax, but I think also things like CSS, images, JavaScript files, not JavaScript execution, but just getting the files, right? Some of these frameworks are a couple hundred megs. Like if you're not somehow distributing that through a CDN, that could be worth considering as well, I think.
Yeah, it is definitely. And so in Python, for example, you've got in Django, there's an extension called white noise. So in Django, you've got static content. There is a really easy extension you can install, because normally you have to kind of configure static and say, okay, my static files are here. And then you have to set up Nginx or whichever web server you're doing to serve that static content directly. So as a bit of a workaround, people often install this white noise extension that basically uses Python as the static server. So like every time you request a CSS or whatever, Python actually is the thing that reads it from disks and serves it back, which is great for like development. But like you should never use that in production because Python is not a very good CDN. So yeah, that's kind of with load testing, you would just test the endpoint and say, oh yeah, it works great. But then you actually run it in a browser. And if you're using something like white noise, it's actually creating, 10 times, 20 times more load than you expected, because it's pulling in all this like CSS and JavaScript and images and stuff like that.
Yeah, it could be out of control. I ran into an issue with my website where I don't know, I got tired of being too careful with font awesome fonts. And I had like missed one. I'm like, I'll just put the whole thing. I'll just put the whole CSS file in. I'm sure it'll be fine. It wasn't fine. Like the web app is running at like 10% CPU usage, and Nginx trying to serve up all the JavaScript is at like 80. I'm like, what is it doing? Like, oh, it was serving up a megabyte sized font stuff every request. This is not good.
Yeah. So yeah, in terms of projects that I've worked on in the past, I've worked on load testing some like big campaigns and stuff like that, particularly around sports events, or some television. Back when people used to watch live television instead of streaming it all, they'd have like a murder mystery or something on a big soap opera, and so I'd like load test the application so that when everyone wants to find out who murdered the vicar's wife or whatever, then they'd all kind of click on the website at the same time and just trying to load test it. So some of the things I'd seen were trying to make sure you simulate browser load correctly, trying to distribute traffic in a realistic way, and then spikes in traffic are basically a different problem. So the thing we talked about, like the halftime problem where you've got everybody turning on the kettle at the same time, that's a special type of load test.
It's a predictable spike as opposed to just an out of the blue spike, right?
Yeah, that one is predictable, which is really nice. And then you get things like seasonal traffic. So for a lot of e-commerce applications and stuff like that, you would expect in the lead up to Christmas or in the Black Friday sale in the US, for example, like Cyber Monday, you'd expect like a spike in traffic for those, but it will be distributed over a day or two. So you want to be able to like properly assess those.
Yeah. Another spike that I think you and I can both relate to is the driver of the day in Formula One, right?
Oh, like, right, yeah.
You've got 10 laps left in the race. Everyone, now go to this thing and press this button, and you have 5 minutes to do it or something, right? Like that's gonna be a mega spike.
Yeah. There can be some big lows in traffic. So yeah, sudden spikes are really hard to handle because you get bottlenecks in the network, you get bottlenecks in the database, you get bottlenecks in the web server. So those are kind of a unique type of problem to test for. If you're looking more at like waves of traffic, so like, traffic would build up during the weekday, or the type of application I have actually gets busier at the weekend or in the evenings, then those are kind of the ones where you test ramped traffic. So all these load testing tools have a ramp up time or a ramp configuration where, so in Locust, for example, you say, how many concurrent users do you want to get to? So let's say that's like 1,000 or something. And then how much do you want to ramp up? And you generally should always use a ramp because, if you've got 1,000 users, unless you've put them all in a room and said, okay, everybody click on the button at the same time, like that's not going to happen. People log in gradually over a period of time. And if you don't use ramping and load testing tools, you actually you kind of end up simulating stuff that's not realistic. So you see like a massive spike in response times as the application gets backed up. But if it's not really realistic that you get those types of spikes, then don't simulate it that way.
Yeah, we're going to talk about it in a little bit, but there's a lot of different layers of caching as well. And if the app has just come to life, many of those layers of caching are not like set up and like warmed up. So that's a big deal. And it could be as simple as the web app parsing the Jinja or Chameleon or Django template, right? That's the very first time that can be slow, but then if you set it up right in production, it will, not parse it the second, third, and fourth request, right?
Yeah, exactly. And so if we talk about Locust as an example, you've got on the screen, I think it's my favorite load testing.
Locust is so good.
Good. It's really flexible, and you define the user flows in Python code. So you write a class that represents a user, and then you program in the steps that they would take. So like, they start on the home page, then they click on this page, then they click on this page. And then you can program in like the pauses and the randomness and stuff like that, and actually set up different types of personas or different types of users. I think this is a great way of designing a load test because you're thinking about what would the user do rather than like what's the throughput. So if you set up a Locust test where they start off at a point in your site, if your site has a login, how many of your users would log in? Because I think it's important to start off. If this is a new application, it's really hard to know. So you're going to have to come up with an educated guess or test like a range of parameters. But if this isn't a website that you've had running for a year or two, and you've got like a history of traffic, then you can look at it and say, okay, how many people on the homepage are logged in? Because there's a big difference. Because when you talked about caching and like CDNs and stuff like that, you can cache the rendered template, but you generally wouldn't cache the whole rendered template if they're logged in, because at the top it might say, hello Anthony, and you wouldn't want to cache that so that when Mike clicks on the website it says hello Anthony, and he's like, who
that
the
would be
hell's
very disturbing, wouldn't
it? So there's a balance between caching and serving up dynamic content, and then also if you're presenting lists of products, or someone's got a shopping cart or something like that, obviously that's unique to them. So you're kind of trying to simulate this as best as possible. Otherwise, you just create these really optimistic load tests where you're like, oh, we tested the homepage and it can handle 50,000 users. But in practice, if 1,000 of those log in, then the whole thing falls apart because all of a sudden you're not using the cached version of the homepage.
Right. Another example that you brought up is, let's just take Talk Python, right? It's got coming up on 500 episodes. If you test, and suppose I put really aggressive caching, like on the database results that come back from a single episode for the page, and then just render that out of memory, basically, at least just out of the objects that are in memory. If you do your test to just hit the one, like let's just randomly pick episode 300, hit that one a bunch of times. Yeah. But in reality, people are hitting all 400 or 500, and it's not all cached the same, or maybe there's so much memory that each one has to hold that it like putting all 500 in memory in the cache like runs it out of RAM on the server, right? All sorts of stuff that happens as you get this kind of dynamic mix, right?
Mm. Yeah, so you want to introduce randomness. So for example, on the login, if you've got a login flow, or if you're clicking on a particular product, then trying not to hard code which one it is. If you've got caching, you might not even see the caching either. Like databases do a lot of caching, so like if you're always pulling the same thing from the database server is probably going to cache that. So it's going to be a lot faster. So if you can randomize the like the inputs or the pages that you click on, or the flows that people take, then that's great. Locust actually has like an extra, when you define a task, which is a decorator on a function, you can have like how often this happens. So you can have some tasks which happen more sort of frequently than others. So you can say, okay, 5 times more people go to the homepage, and then, every so often somebody does a search. But then when you do the search, when you want to load test the search, you want to randomize that a bit more than just always searching for the same thing.
Right. Yeah. And just so for people who haven't seen Locust, you create a class, you give it a couple of functions, and then, for example, to test the homepage, you just literally put the task decorator on the function. You say self.client.get / self.client.get maybe some additional assets or not. And then you can even hard code into the class what the domain is, or localhost, or support, or whatever. And that's it. And you can assign a weight to these tasks, like homepage 5 times more likely than about. So just put task of 5 instead of task by itself, right? It's incredible.
Yeah, it's really, really helpful. And then there's a library. There's a couple of things you need to keep in mind as well. Like if the user logs in, and then it probably creates some sort of session, whether that's like a cookie or a token or something like that. So you need to store that somewhere in the class so that subsequent requests use the same login session. And then also, frameworks like Django and Flask have got cross-site request forgery protection. So they generate these CSRF tokens in the forms as well. So there's normally like a bit involved in getting the cookie or the session ID, getting the CSRF value, and then like, so if you're submitting forms or you're like doing a search or something, you need to code a bit in Locust to work around like the security controls.
Right. For example, you might do a request to the page that has the form and then pull back the CRF token from a cookie and then use that as part of the form submission data. Otherwise, it might just say invalid. Another one that would be really tricky would be like turnstile or reCAPTCHA. You're probably basically not getting that. Not worth
it. Yeah, you're stuck there. You've got to fill in those ones.
Just maybe turn it off real quick for your test and then turn it back on. I don't know. I mean, you could do it, turn it off in development or something like that, right?
Yeah.
So when I look at this Locust stuff, I see behind the scenes something like requests or HTTPX, where all it does is pull back the string of the HTML, or maybe even it just gets the head and actually throws away the content. I bet it streams it back. But what I don't imagine it does is it doesn't parse the HTML, realize that it's a Vue front end, execute the JavaScript that then has 3 API calls to more stuff on the back on the server, right? It doesn't, if it's a rich front end app, it probably doesn't treat it the same if we write it just like this, right?
Yeah, so the other one I wanted to highlight is it's an extension to Locust, so you can connect it with Playwright. It does HTML parsing. That's more like looking at the HTML to see if like a particular, like a Beautiful Soup or responses was the framework for this.
Right. Make sure timeout does not appear in the text or something like that.
Yeah, make sure the page doesn't have error in big letters. So like that's one thing you can do, is checking that the content of the page actually contains the right thing. And then Playwright is a UI like a web testing tool. Playwright works really well with PyTest, so I recommend using Playwright anyway if you're running a web application, because you can write PyTest tests in Playwright. Even better is if you want to get started with Playwright, it has a code generator. So when you pip install it, you can run it in the code gen mode. It pops up a browser, and then you just go on your website and just click around and then do what you would do normally, type in, fill in the forms, click on the buttons. And then whilst you're doing that, in another tab, it actually generates all the Python code for the PyTests. So it basically generates the PyTest test code in a separate window automatically as you're clicking around in the browser. So like in terms of writing UI tests is quite difficult, because often you have to be like, okay, how do I find the button? How do I click on the right button? How do I find the form? Especially with JavaScript, because it's not, often things don't have a specific ID, or you've got to figure out what selectors to use and stuff like that. So this makes it a lot easier because you can use the code gen. So that's a browser test. So with a load test, normally in Locust, you're just making HTTP requests, but you're not actually rendering the page or running the AJAX or the JavaScript code. Whereas with Playwright, when you run Playwright, it's actually spinning up a browser and then driving the browser from Python. So you can plug Locust and Playwright together. There's a Playwright extension for Locust. So you can say, okay, each load test user, I actually want that to be a browser. And so when you say I want to test 100 concurrent users, it actually spins up 100 browsers. In a very well, Playwright's actually really interesting how it works, but like there's a headless mode for browsers these days. So it doesn't actually run 100 windows, like you can't see them.
I can't use my computer while this is running. It's just overwhelmed by.
But yeah, I don't recommend running 10,000 concurrent on a single laptop, because it's gonna run pretty slowly.
It's gonna have a bad time, yeah. But that is really important to actually. So that will test it. All the stuff that we've been talking about. It'll test if there's polling. It'll test that. It'll pull if the CSS is not delivered over a CDN, it's going to go get that from potentially white noise or wherever it's coming from, right? It's going to do all the things.
Yeah.
Yeah.
Yeah, the challenge with it is that, like you mentioned, running a browser, even if it's just a tab, uses a lot of resources. Whereas making a HTTP request using a request or something, doesn't really need anything. So you can quite happily in Locust, make 100,000 requests, and your
Yeah.
local machine that you're testing on will be fine.
It will.
So yeah, you can actually get load testing as a service. And the reason you'd probably want to use that is if you're testing a scenario where your local dev environment or your test environment just isn't big enough, or you need to distribute it. Then you need more horsepower basically to go and run all the requests, especially for something like Playwright, or where you need a lot of resources for the browser.
Yeah. Yeah, the little screenshot they have for Locust says 21,400 users are currently accessing the website. It's like, that's a lot of browser instances, browser
That's a
tabs.
lot of browser instances. Yeah, that looks like an API test, which would be a lot easier to do.
Yeah. APIs are easy.
Yeah, so we there's a service called Azure Load Testing. There is other options as well. I'm sure AWS has one, and Google probably has one as well. Azure Load Testing, I know, and we are launching Locust support for that. At the moment, it supports
really?
JMeter tests,
Okay.
but yeah, we're going to be launching Locust support for that. I think by the time this episode comes out, it will probably be in public preview. So I've been using that and testing that. And the reason you would use it is, like I said, if you can run the Locust test locally on your machine and it runs great, then brilliant. But you can ask us to spin up 50, 100, or even more instances running in parallel. And so if you want to do a really large scale test, then you can just basically get that from a cloud service provider like Azure.
Yeah, awesome. I didn't realize you guys are bringing that online. That's cool.
Yeah, nobody knows about this.
Yeah. Can you do distributed? I think you can do some distributed stuff with a Locust even, can't you?
Yeah, you can.
But you got to have your own infrastructure, right?
Yeah, and a lot of it uses SSH, and you've got to basically it kind of works over the shell.
Yeah.
So yeah, we've kind of got our own distribution and coordination system and stuff like that. And then also when you're running the test, your output, I guess, is what is the response time of the pages, and what does that look like? And I think what confuses a lot of people is the first time they use Locust or JMeter or one of the other tools, they get all these percentiles back, and they're like, oh, the 90th percentile response time is this, and the 95th is this, and the 99th is that. And they're like, okay, well, if I go back to my high school math, I think I can remember what percentiles are, but which one matters? Because normally there's a massive difference between the 90th and the 99th percentiles with load testing. And you might see, oh, well, the 99th is 10 seconds, but the 90th is 300 milliseconds. So, was that a good output or a bad output? I'm not really sure how to interpret the results. So yeah, you'll see in the UI for Locust, it gives you percentiles. All the other load testing tools are very similar. It's basically like a distribution of the response times for those particular pages. And what you're trying to understand is what is the expected response time. So if it's a bell curve, then what's the center point of that? Because the 99th is interesting, but often it's because the cache was warming up, or there was one user that took 10 seconds.
The cache expired and then it got recreated right then or something.
Yeah, exactly. So for the 99th percentile, if it's 10 seconds, you might have one user that took 10 seconds and 99 users that took, a couple of 100 milliseconds. So it's, do you want to factor for that one user, or do you want to focus on the other, on the bulk of the group?
Yeah. And if you're like my daughter, you'll just say that the internet's broken.
Yeah.
Like, it could be, or it could be that YouTube is slow for some odd reason for you for a minute. Like, it's not necessarily the entire internet that is the fault here.
Yeah, well, most users, I think, if it took 10 seconds to respond, would just clicking the refresh button.
Yeah, exactly.
So just generate more load. Yeah, you might have to program that into your load test. If it takes longer than 5 seconds, then issue another 3 requests.
Yeah, that's a really good point, actually. Let's see. Are there any pictures of the reports here? Let's see. There we go. Maybe. Yeah.
Yeah, you
here.
get these nice graphs that shows you response
nice.
times. Yeah.
They're not just graphs, they're live graphs. You can kind of see it like flowing as it's testing, right? As it's ramping up or whatever.
Yeah, definitely. So what we do with the load testing services is we've got that graph, but then you can also say, I also want to see how many queries a second were happening on the database, what was the memory usage of the web applications, like how many, like what was the pod size if you're using Kubernetes, like stuff like that. I've got a couple of demos where I've got like parameter-based load testing, where when you're setting up a Kubernetes environment, you're like, oh, I'm not sure how much memory I should allocate the containers, or like how many of them I should have in a pod. So you can basically just use something like GitHub Actions to give a matrix and say, okay, I want to test these configurations. Let's see what happens with 0.5 gig of RAM per container or 2 gigs of RAM per container. Let's do 2, 4, 8 in a cluster. And it will run the same load test for every configuration. And then you can just compare all the graphs and say, okay, we don't want to over allocate infrastructure, because people often go a bit nuts. They're like, oh, how many instances in a cluster do we need on the front end? And they allocate like 16. But then when it's actually running, 15 of them are idle. So it's kind of just over provisioning. So load testing can be a great way of not just like planning for spikes in traffic or being able to like cater for it, but actually the other way around, which is you run a load test and you realize you could probably actually do with less infrastructure.
Yeah.
So like things like memory as well, like memory is expensive when you're buying it from a service provider. And CPUs and stuff like that, or the number of instances. And actually, let's see what happens if we turn some of those things down. Will that impact the response times? Can we get away with it, basically? Because in a lot of cases, you can actually spend a lot less money and get the same performance, or even just a negligible difference.
Or maybe you identify somewhere where you could add some level of caching.
Yeah.
Then all of a sudden, you can prove you get 10x the load per worker process. You're like, we could have a smaller machine or smaller cluster or whatever.
Yeah, exactly.
So one thing I would like maybe to talk to the folks about is just, how do you interpret these graphs? So you have like a request per second, and then you talked about, say, the 95th percentile response time, and this ramping up. And usually when you look at these graphs, it's really obvious, like, yeah, we can add more users, but here is where we start to suffer consequences if we add any more users than this. It doesn't always just completely fall over. It just behaves worse.
Yeah, so it's kind of a bit like a feedback system for anyone who studies those. When you configure a ramp in Locust, you're saying, okay, how many users per second do we want to add? And you start off with a slow ramp, is my suggestion. So like, every 10 seconds, add 1 user. Would like be a really slow way of doing it. And then what you're looking at is the response times for each page, or you can get an average of everything. So if you're starting off with a load test that just tests 1 page, you slowly ramp up the users, then you're looking at the response time graph. Often when you run a load test, when it starts, the response times spike up at the beginning, because the service was probably asleep, the database server was probably asleep. It needs to like kick a few things into action to get it responding. So you often see like a spike at the beginning. That's fine. Don't worry about that. As long as it's a short spike and it doesn't go on for hours. But we know once everything's warmed up, then you should see a stable graph. So the response times should stick around the same level even as you add more and more users to a point. So it's basically looking at the two graphs, which is the response time and the number of users, and trying to understand how many users does it need to get to before that response time line starts going up. And you basically know that's where you've introduced some sort of bottleneck.
Right. Something
So that's
reaching
where
its limit. Yeah.
that's where someone, people are all of a sudden sitting in a queue somewhere. The hard part is actually figuring out where that queue is. If you don't have the time, but you've got the money, you can just throw more infrastructure at it. But often you can fix some of those queues by looking at what are we caching and where.
Right. Look at the CPU usage of the various aspects. What's the database CPU load? What's the web process? If the web bit is kind of chill, but the database is at 100%, maybe you need better indexes or something.
Yeah, because often you look at it, the infrastructure on the back end, and even though the response times are going up, so there's a bottleneck, the CPU's maybe still at 60%. And the memory might only still be at 50%. So you're like, okay, more CPUs isn't necessarily the issue, but things are getting stuck somewhere. And that might be that, each page, actually, I remember one load test I did, where it was a PHP application using like some framework, and the performance was horrible, and we couldn't figure out why. And we put on some debugging tools and realized that every single page ran 200 SQL queries, because of the way they'd written it. It was like, oh, that'll be why. Because you're looking at the CPU and memory of the actual web servers, and they're fine. Like the web servers are just basically just sitting there, continually waiting for the database server to respond. So you look at the resource usage, and you might be thinking, well, why is it getting slower? But often it's because you're making calls to a database or a backend API or something. And it's just sitting there idle, waiting for the responses. So, I know you mentioned on the show a few times, but like the N+1 issues and stuff like that for ORMs in particular is where you get those types of scale where you should not be seeing that many SQL queries.
It's so easy to do because you write the same code, get the things, and then loop over and interact with some aspect of them. And if you don't eagerly do the query at the first part, each one of those is a separate query. The more you get back, the worse it is.
Yeah, exactly. And I mentioned like an AI app, like with this LLM RAG app that we did a load test on with like 10 users. And like the CPU and memory were fine on the front end because it's not really doing anything. It's just calling the LLM. But it hit like a token limit like really, really quickly. And because we were capturing that and tracing it, then we could see like that's what the bottleneck was, that it was getting rate limited on the back end.
Yeah. So I think one of the challenges that people can run into, this is really important, is testing with way less data than you're going to have in production.
Mm-hmm.
I've got 10 entries in the database because that's what I bothered to type in while I was playing with the app, but I've got 1 million in production. Stuff like that, right? Or I've got 3 products and there's 1 million in production.
Yeah, so go, Mike.
No, go ahead. You actually had some really interesting tools that you recommended to deal with that.
Yeah, I'd seen this a few times where people have done load testing and they're like, oh, on the all users page or on the list products page, like it runs super fast. Because they've deployed the dev environment and it's got like no products in the database.
It doesn't matter if you have indexes because there's only 3 things, just return them all.
Yeah, or and you don't see things like the N+1 because there's only like a couple of products, if any at all. So you often want to seed the application with as much fake data as possible. And the library that I absolutely love for this is called Mimesis, which is a fake data generator, kind of similar to Faker, but it's got a lot more support for like different languages and environments and stuff like that. So if you wanted to say, okay, let's create 100,000 users, and you need to generate names and addresses and locations and stuff like that, you can do that using Mimesis really easily. And also, if you want to do like test like different cultures or locales, so not just testing like English names, but testing all sorts of different countries and stuff like that, or different phone numbers, then yeah, you can use Mimesis to do that.
Yeah, it's got all kinds of different things. You get credit cards and phone numbers and
yeah,
all
you can
kinds
say
of stuff.
I need 100,000 Brazilian phone numbers, and it will just give you them in exactly the right format.
Yeah, so then you save those to your database once,
Yeah.
and then you can run your tests and see if you have your N+1 problem, or if your indexes don't fit into memory, or whatever the problem might be, right?
Yeah, so for Django or for SQL Alchemy, you can do these load and dump commands. So what I kind of recommend is to keep it fast, is to use Mimesis to generate a seed data file, even if that's like JSON or something, and then just do like a bulk load in the test environment, and then you can reset it every time. So you can basically just do a rollback and then just reset and do a bulk load. If you're using like a document database, then they've got similar tools for that. So if you're using Mongo, then you could just do a bulk load from like a test command, basically.
Right, just load it up with some fake data, do a Mongo dump, and then whenever you're ready to reset it, just do a Mongo restore -- drop, and it'll recreate.
Yeah, exactly.
Yes. Yep.
And you can reuse those for your integration tests as well. If you've got integration tests with Django or Flask, then often you need a database fixture and you want to seed that with some information, then you can just reuse the same data.
Yeah. Could also do transactions, right? Like put a transactions that's always rolled back. So once you load it up, you're not breaking it. But that's tricky if the code itself calls commit, I suppose.
Yeah.
No, it changed it. Darn it.
Yeah, there was a question in the chat: how does load testing change when you have non-deterministic processes, e.g., LLM queries? Which is a really good question.
It is.
And I think it's kind of related to this, where you've got you want to introduce like an element of randomness, but we talked about like a user search page, or if you've got like a chat feature or something, then you want to kind of vary the question, especially if you've got any kind of caching. So that is tricky though, because at the moment, like the LLM calls, depending on which model you're using and how it's set up and stuff like that, but they can take a second up to 10 seconds to get a response.
Easy, yeah.
So you need to kind of factor that in. Is like, how does your app handle sitting and waiting for 10 seconds before it gets a response back? And often you'll find that you'll max out the number of like threads you've got, or the number of workers in like gUnicorn or Uvicorn or something like that, because they're all just sitting there waiting.
That's a place where async and await would be pretty awesome.
Yeah.
Right, because you can sort of let the thread go and just you'll get back to it. Also, maybe you just need a different architecture. Maybe it's not just more caching or more hardware. It's like, so we're gonna put there's a pending request in the database, and we're gonna push that off to somewhere, and then we'll just set up like some kind of JavaScript thing to check if it's done, and then pull down the answer, or something that's not necessarily blocking potentially.
Yeah, async and await is great for, like you mentioned, great for that. Actually, there was an announcement pretty recently that you can run Uvicorn now, like as a production.
Directly, without without being wrapped through gUnicorn. Yeah, that's awesome.
So yeah, for this kind of scenario we just talked about, where you're waiting on backend calls and stuff like that, use the async version of those libraries, Like if it's OpenAI, there's an async version of the OpenAI SDK. Use that, and then at least like Uvicorn is going to just have, it will quite happily run like hundreds and hundreds of those requests that are just waiting on backend calls.
Yeah, absolutely. So one thing I want to throw in here, this is coming from me, not from from you, but I want to get your thoughts on it. So I recently set up this thing called Uptime Kuma. Are you familiar with Uptime Kuma?
No.
So this is an open source, self-hosted uptime monitoring tool. And you just run it in Docker, off it goes. And one of the things that's nice about this is, well, over on Talk Python now, if you go to the bottom, it's got a server status, and you can come in here, you can see the website's behaving well, the RSS feed is behaving well, the courses size, but also the mobile API, all these things. But the reason I think this is, I mean, status, like, is it working or not, is not really that relevant. That's like an operational thing. But what's cool about it is if you go and dig into the thing, you go to the dashboard, like, let's say, you could even group them, right? So like, let's do this. I'll do the API. So for like the mobile apps API for the mobile app for Talk Python courses, you can actually see over time what it's seeing in response time for like days. So, and with your load tests, you're saying, let me just hammer it and see how it responds to that, right? And if you point something like this, or there's many other tools like this, but this is a nice one. You can just say, just keep a record and let me go back and look for, for 24 hours, how has the load looked? And you can see there's some weird spike there. It probably did like a deployment like right around then or something. But in general, 40, 50 milliseconds, 35, 81, right? It's handling it. Because if the thing was overwhelmed, then these tests would also suffer the latency that everyone else is suffering, And this is like every 30 seconds.
Yeah, that's really cool. I do want to give a shout out to OpenTelemetry. I hope more people, every year more people find out about this, and they're like, oh, this solves a lot of my problems. It's a CNCF project. It's a big open source standard. It basically is a standard for instrumentation, like an observability. So it's you kind of plug these instrumentation libraries into your app, and there's ones for Fast API, Django, Flask, like the backends, like Mongo, like SQL Alchemy, stuff like that. And you basically just install these pip packages, and it will just start to capture all this information about, oh, there's a request and it had these parameters and it took this long. And so in Python, like with a very small amount of code and a few pip packages, you can instrument all this stuff in your application. And then the other thing that OpenTelemetry does is it's kind of like a pluggable exporter. So wherever you want to send all that data to, you can kind of pick and choose like which platform you want to send it to. And there are some like local ones you can use as well. Like you showed this tool for Uptime. There's some Docker containers for that. So like you just spin up a Docker container and it will just take all that telemetry data and give it to you in a GUI. So you can see like all the traces, how long they took, what calls it made on the back end, what queries it was running. Like OpenTelemetry is a brilliant way of doing that. And it's not just Python. Like if you've got some components of your application that are written in other languages, like odds are that it is also supported. So it's kind of like a framework, I guess, for capturing data. And when you're doing load tests, this is how we do like postmortems to figure out, or even just looking at the stats and seeing like, where did things go slow? And I've got some videos and stuff of demos I've done with this, where I've got like applications, I've done a load test on them, and then I can see, oh, there was a spike in load. Let's go back and look at the data to see what caused that and which calls was it, what was the resources, the memory usage, and often like, was it the database or was it an API call? And Why did it take so
Right.
long? What were the special parameters, stuff
Right.
like that. So you
What were
you
we
just
waiting on? Was it the actual web app or was it the database? But like you can retroactively know that, right?
yeah, and OpenTelemetry is a great way of doing that.
Yeah, that's super cool. That's way more holistic than my just give me a graph of response time.
Yeah, that's still cool.
It's still cool. It's 20 minutes to set it up in the Docker cluster.
Yeah.
Awesome. Well, let's talk about, I know we're basically out of time, Anthony. Let's just talk really quickly about one thing that I think is a little bit tricky, and maybe just to get your thoughts on, my Vercel example of cost is sort of in this space, and that's serverless. So what are your thoughts
Yeah.
on serverless? Like, you have way more control when you have a VM or you've got a Kubernetes cluster or whatever it is you're working with, right?
Yeah, it's kind of a bit. Yeah, I don't know. I always kind of see serverless. It's a really cool idea, but it's more of a commercial concept than a technical one. um,
Yeah, I'm thinking more about just you don't control the warm up.
yeah,
You don't control the machine. There's just a lot of stuff that's
yeah.
black box to you,
I think most of the platforms and most of the providers have got like a range of options. Like I speak to Azure Functions, which is like our serverless Python engine. You can use that as like just pay per request. But it then has certain optimizations so that it has like a warm startup time. So if you haven't made any requests for a certain number of hours, then the application will fall asleep. So it's not using resources, and we're not charging you money. But if you don't want to have that, if you want the startup time to be super fast, then you can use a different service level basically and have like faster startups. You can have like pre-allocated resources, which it then becomes not serverless, but it's the same framework, it's the same architecture, and Lambda's the same. AWS Lambda's the same. You can kind of set it up in those different options. Things kind of get tricky when you get into Kubernetes because you've got real infrastructure on the background. And when you look at Kubernetes clusters or Kubernetes as a service or however you're setting it up, the first question is like, how many VMs do I need to provision and how big do they need to be? So yes, you're kind of building like a serverless abstraction on top of it, but you've got real infrastructure in the background. And that's actually really hard because in a lot of cases, you've just got tons of idle infrastructure. So I think load testing is a good way of looking at like trying to right size what you've got provisioned, and in many cases scaling down some bits and scaling up others.
Yeah, absolutely. I don't mess with Kubernetes. It's too much for me. I don't need all that. I don't need all that stuff. I do use Docker though, which is really, really nice. And I know a lot of these tools we talked about support running in Docker or working with Docker and so on.
Yeah.
Yeah. All right. Well, hopefully people have some really concrete ideas and tools that they can use, like Locust.io, which we're both huge fans of. Playwright, same deal, but also some of the philosophy and ideas behind it, which is super important too. So much appreciate you coming on the show to sharing that, and just the chance to catch up. How about you give us a quick wrap up, important takeaways for people who want to go out and test their stuff now?
Yeah, so I think step one is to look at your application and understand what your users are likely to do. So if you want to design a load test, start simple. Maybe even start with Playwright, because you can just spin up the browser recorder, click around in the website, and simulate what a user would be doing. Stitch that together with Locust and test 10 users. Don't go nuts. Start off with a small number, a simple test, and you will uncover things that need optimizing. I don't think I've ever encountered an application that just ran really efficiently the first time. And then just keep working on that. So yeah, instead, because often you would end up trying to optimize things that are not going to get touched or don't really make a difference when you actually test it. So yeah, start simple. I recommend using Locust and Playwright if you want, or you can just write a simple Locust test, and then put the instrumentation in the back end so that you can see not just the response times, but you can see as much data as possible on what's happening and how long it's taking. And I'll share like a couple of links of some simple dashboards you can use with OpenTelemetry, where it will capture that data locally or in the cloud, and show you, a trace of every request.
Yeah, awesome. And do that with real data. Don't do it with
Do it
3
with real
entries.
data. Yeah.
It's not gonna mean what you think it means if you do it with only 3 entries.
Yeah.
Awesome. All right. Well, always great to have on the show. Thanks for being here, Anthony. Catch you later.
Yeah, it's great to be back. Thanks, Mike.
Yeah.